Australia's empty heart. The land, the silence, and what lies beneath Australia is famous for its beaches, its cities, and its wildlife. But most of the country is something else entirely. Vast. Empty. Quiet. Fly over Western Australia and you see it immediately. Endless red land stretching to the horizon, broken only by dry riverbeds and low ancient hills. Few people live here. Few roads cross it. And yet, this quiet interior has shaped the modern world more than almost any other place on Earth. Beneath this landscape lies one of the most important geological regions on the planet. Not because something new was suddenly found here, but because scientists began to understand this land differently. What changed wasn't the rocks. It was the story we tell about them. The Pilbara region, that built the modern world in the northwest of Western Australia, lies the Pilbara, a remote region larger than many countries. To travelers, it feels timeless. Harsh sun, rust-colored ridges, a sense that the land has barely changed for millions of years. In one important way, that feeling is completely accurate. The Pilbara contains some of the oldest exposed rocks on Earth. Long before cities, before forests, before complex life, these rocks were already here. And today, they support an industry that quietly underpins modern civilization. The iron mined from this region becomes the steel in bridges, buildings, railways, ships, and power stations across the globe. Entire towns, ports, and rail networks exist here for one reason: the geology beneath the surface. For decades, scientists believed they understood this story well. The iron was ancient. The ore formed early. The system was simple. But the land had a longer memory. A discovery. Without a discovery. Why this story isn't about finding new gold. Or iron. When headlines talk about massive underground wealth in Australia, it often sounds like a dramatic discovery, as if someone suddenly uncovered a hidden treasure. That's not what happened here. No new mine was found. No untouched deposit was suddenly revealed. Instead, the change came from laboratories, microscopes, and chemical measurements. Scientists didn't ask where the iron was. They asked when it truly became usable ore. That question matters more than it sounds, because not all iron-rich rock is ore. Ore is rock that nature has refined enough to be extracted efficiently. And if that refining happened later, or differently than we thought, then the scale of what exists changes dramatically. Not physically, but economically and strategically. Ancient oceans. How the Pilbara's story began to understand this land. You have to go back more than 2 billion years, to a time when Earth looked nothing like it does today. The Pilbara was once beneath ancient oceans. These weren't coral reefs or sandy beaches. They were chemical seas, rich in dissolved iron. As oxygen slowly began to appear in Earth's atmosphere, that iron reacted and fell out of seawater, settling onto the seafloor in thin layers. Iron, then silica, then iron again. Over millions of years, this process built enormous sheets of banded iron formations, rocks striped with alternating layers, recording slow chemical rhythms in an early Earth. Similar rocks exist on every continent. On their own, they aren't special. What happened next is what made the Pilbara different. The land that was prepared. When the Earth quietly set the stage. Long after those iron layers formed, the region was reshaped by deep geological forces. The crust folded. Faults fractured the rock. Pressure and heat slowly transformed the landscape from below. Hot, salty fluids moved through these fractures, altering the chemistry of the iron formations. Minerals dissolved. Others grew in their place. The rocks became more porous, more reactive, more open to change. This stage didn't create valuable ore yet, but it did something essential. It prepared the system. The Pilbara became a land ready to be transformed, even if that transformation wouldn't happen for hundreds of millions of years. Then, for a very long time, nothing seemed to happen at all. When the system woke up again, a second life beneath the surface. Roughly 1 billion years later, something remarkable occurred. Fluid circulation returned. But this time, the chemistry was different. These fluids carried oxygen and moved through the landscape on a massive scale, guided by folds, faults, and ancient structures. As they passed through the iron formations, they stripped away unwanted minerals and concentrated iron in place. Magnetite changed into hematite. Other minerals dissolved and disappeared. What remained was iron. This wasn't shallow surface weathering. Evidence suggests these processes happened deep underground, at high temperatures, across enormous distances. The Pilbara effectively became a vast underground chemical network, quietly upgrading its own resources. Some areas progressed further than others. Some stalled. Some reached extreme purity. Geology decided the outcome, a landscape that preserved the past. Why the Pilbara still exists, as it does many regions, experience similar geological processes. Few preserve the results. The Pilbara did. After this deep transformation, the region remained unusually stable. Mountains didn't erase the evidence. Glaciations didn't strip it away. Erosion was slow and selective. Later, surface weathering polished what already existed, gently improving quality rather than creating it. The result is a rare geological record, layered, preserved, and accessible, beneath one of the most sparsely populated landscapes on Earth. For travelers, this explains why the land feels ancient. Because it is. Why timing changed everything. The question that rewrote the story for decades. Scientists assumed the Pilbara's iron ore formed soon after the original rocks were laid down. New research suggests something very different. Much of the refining may have happened far later than believed, after the rocks were already old. That shift in timing doesn't create new iron, but it changes how much of the existing rock qualifies as high-grade ore, and how resilient the system may be over time. It also raises a bigger possibility. If this happened here, it could have happened elsewhere, in places previously overlooked. Understanding timing expands the map. More than rocks. Why this matters beyond Australia, iron is invisible in daily life, but it supports almost everything around us. Roads, buildings, energy, transport. Australia's role in supplying that iron influences global trade, national planning, and long-term infrastructure decisions. A better understanding of how these systems form and how long they last shapes the future in quiet but powerful ways. Yet the most important lesson here isn't economic. It's philosophical. The real discovery. What the land teaches us nothing. In the Pilbara suddenly appeared. The rocks didn't change. The land didn't move. What changed was our perspective. The most meaningful discoveries often don't come from finding something new. They come from asking a better question about something familiar. In this case, the question wasn't, where is the iron? It was, when did this land become what it is? And the answer reminds us that Earth doesn't give up its stories easily. It reveals them slowly, to those patient enough to listen.